Hi everybody, it's Mrs. Dunn. We're talking about symbolic arguments today. This is going to be a pretty long screencast, so let's get started. What we're going to be doing is determining the validity of a symbolic argument by using truth tables or by using a standard argument, a recognized form. And then we're going to determine a logical conclusion from a set of premises. Okay, so we're talking about arguments today. An argument can be either valid or invalid. If the argument is valid, then the conclusion follows from the set of premises. And if the argument is invalid, then those conclusions do not necessarily follow from the set of premises. Let's look at some examples. Here are the standard forms or recognized forms of arguments. There are 4 that are valid and there are 2 that are invalid. The valid arguments have special names. They're called the law of detachment, the law of contraposition, the law of syllogism, and the disjunctive syllogism. The invalid arguments are the fallacy of the converse and the fallacy of the inverse. Let's look at examples of each of these. So the first one is the law of detachment. Now let's understand how we organize or construct the argument. These 2 statements that are above the solid line are called the premises. The statement that is below the solid line is called the conclusion. These 3 dots, maybe you remember, are a symbol for therefore. So the way this argument would be phrased is, if you go on a diet, then you will lose weight, is the first premise. You go on a diet is your second premise. Therefore, you will lose weight. So if you go on a diet, then you will lose weight. You go on a diet, therefore, you will lose weight. This is an example of the law of detachment. If you go on a diet, you're going to lose weight, and you go on a diet, so therefore you lose weight. Let's look at the law of contraposition next. The premises are, if you go on a diet, then you will lose weight. You do not lose weight. Therefore, you did not go on a diet. The law of contraposition. Let's look at the law of syllogism. If you go on a diet, then you will lose weight. If you lose weight, then you will fit in the dress. So therefore, the logical conclusion is, if you go on a diet, then you will fit in the dress. Aren't these kind of fun? And lastly, we have the disjunctive syllogism. This is the last of the recognized valid forms of arguments. So the premises are, you will go on a diet or you fit in the dress. You do not go on a diet. Since the premise was you will go on a diet or you fit in the dress and you do not go on a diet, then it follows the logical conclusion must be you fit in the dress. That's the disjunctive syllogism. Okay, what about those fallacies? So consider this statement, if you go on a diet, then you will lose weight. You lose weight. It does not necessarily follow that you went on a diet. That is considered the fallacy of the converse. Next, you have, if you go on a diet, then you will lose weight. You do not go on a diet. Then it does not necessarily follow that you will not lose weight. This is considered the fallacy of the inverse. So understand these 2 arguments, these last 2 arguments, were examples of fallacies. These were not valid. Okay. So now what we're going to do is determine whether an argument is valid. Here is the procedure. I'm not going to read the words to you. You can pause the video and look through this. But basically, the procedure is we're going to write the argument in symbolic form. Then we're going to look to see if it's a recognized form. If it is not a recognized form, we're going to construct a truth table, and then we're going to complete the truth table to determine if the argument was valid or not. Let's go through some examples. So let's start with an argument that is already in symbolic form. So this is the biconditional P if and only if Q, Q if Q then R, those are the premises, therefore if not R then not P. This is definitely not a recognized form. We don't have any biconditionals in our recognized forms. So we're going to have to construct a truth table for this. The way you construct the truth table is you take the first premise and the second premise and join those with an and statement. And the therefore becomes a conditional, or the arrow, and then we're going to write the conclusion. So I'm going to do this in steps. I'm going to try to go through this pretty slowly, but feel free to stop the video if you need to. Okay, so here's my truth table. This is the beginning of it. I have three statements, P, Q, and R. The first premise is if P, if and only if Q. So I've put that in parentheses. I'm joining the other premise with a conjunction in the middle. The second premise is if Q then R. Those are joined together, like I said, with a conjunction, and they're in a bracket. So thinking of order of operations, I have to do this parenthesis, and then the and. The conclusion, highlighted in orange here, is written last. It's in parentheses. And the bracket, everything in green, is joined with the conclusion, which is in orange, with a conditional, the conditional arrow. All right, here we go. So I filled in P, Q, and R. You know those are always filled in. You know what those are. And then I completed this parenthesis with the biconditional. I completed this parenthesis with the conditional. And I completed the conclusion, which is this conditional. Feel free to pause, do your own truth table, see if you get the same answers as I did. Now, I have to finish the bracket. That's the part that's on the left, this part right here. Okay, so I have to join the biconditional inside the bracket with the conditional inside the bracket. So I'm going to fill in this and column next. So remember, true and true is true. True and false is false. And you can go down the line and finish these. So this column is just two trues, the rest of them are false. We already had the conditional on the right, so the next step is to join the conditional in the conclusion with the conjunction in the bracket. And those are the two columns that are going to determine this conditional column. So we're going to use the rules. If true, then true is true. If false, then false is true. On down the line. And you'll notice that the answer column is all trues. If the answer column is all trues, we have a tautology. And if the statement is a tautology, that argument is valid. So that was an example of a valid argument. Okay, now let's take an argument that's in words. Joe is a golfer, or Bo is a football player. Charlie is a runner, and Joe is a golfer. Therefore, Bo is a football player. The first thing we're going to do is write these statements in symbols. So, P I'm going to define as Joe is a golfer. Q is going to be the statement that Bo is a football player. And R is the statement that Charlie is a runner. So now I'm going to take these statements and use these symbols to write this argument in symbolic form. So, Joe is a golfer, or Bo is a football player, P or Q. Charlie is a runner and Joe is a golfer, R and P. Therefore, Bo is a football player is therefore Q. Now that I have it in symbolic form, I'm going to construct that truth table. Remember, the way we construct the truth table is premise joined with premise, and there's an and between those. Therefore, Q. Premise and premise, then conclusion. It looks like this. So now let me put the PQs and Rs in there and fill in the first parenthesis and the second parenthesis. I also completed the conclusion. Take a minute, pause it, construct your own truth table. You need to know the rules of these truth tables. It's extremely important. You won't be able to do this section if you don't know the rules of your truth table. Okay, what's next? What am I going to do next? You answer that question. Yes, now we have to do the conjunction. So I'm joining these two columns to do the conjunction. True and true is true. True and false, false, on down the line. Now what do? What two columns determine the answer column? That's right. It's the conjunction and the conclusion. Those are what determine this conditional column. So do the truth table. Use the rules. If true, then true is true. If false, then true is true. If true, then false is false. Complete the table. So look at what we have here. The answer column here is highlighted in this light orange or yellow. And what you see here is I don't have a tautology. One of these truth values is false. And because one of them is false, it's not a tautology. The argument is not valid. All right, that was a lot of stuff. Hopefully you'll do well with this. You know you can email me anytime. Good luck.